Hi guys, I'm Peter and today I'll do a small tutorial about Ice Magic Rain or something like this. In general, I would like to provide some tips and tricks about where you can get some really cool assets, specifically projectiles and particle systems. If you don't have artists right now or you don't want to spend time in your current state of development, if you need some kind of magical spells and special effects to have for a, let's say, prototype game. So in the marketplace of Unreal Engine 4, you have here amazing thing. I'm pretty sure you know about that, but just in case you don't, there is this elemental demo, and aside from looking really good, let's open it. There is plenty of assets inside, so you can find fire, you can find different rocks of ice and flames and stuff and things. And we will take some of them, we will migrate them to our project, and then we will try to do something fancy with them. Let's see how it goes. I hope this won't take much time. And if you're watching this, you can already see how much time it take. And yes, Elemental Demo is kind of big thing, so it takes hell of a time to load. Let me just actually disable my fan. You know, it's 32 degrees Celsius here, so it's really hot, and without a fan it's really hard to keep mind in a cold state. Okay, so apparently it's opened, or it's gonna open in mere seconds. Yeah, let's see again. Okay. Yeah, great. No, please don't compile shaders again. Okay, here we go. This is Elemental Demo in unlit state. And we will take some assets from here. So you can see here I already have opened Elemental Character Ice Knight FX folder. And there are some nice assets. Let's look at this thing, for example. Okay. This is a rockfall, but we're not interested. So we're going to make ice projectile. So let's take this asset, for example. Please don't load so slow. I need a better PC. Much better. Significantly. Okay, this is the one thing. Breath Blast. And then we have this Eye Burst, I guess. Or, yeah, probably Eye Burst is fine. Yes, probably. Or let's see, Eye Flare. Yes, Eye Flare is the better one. So we right click, and we assume that you already have a project set up. But here are all the assets that will be needed to make this work. This is a migration editor report, and please find your project folder. I'm using a simple first-person project reference. So I have it somewhere here, I guess. And yeah, ref first-person blueprint. And this is a blueprint tutorial, if you don't know yet. So we go into the content, we say, okay, import here. It did successfully migrate. Okay, then let's take this one. And let's do the same. Migrate, yeah. And the folder that you selected previously is already selected here. Yes, we can replace, we might not replace, but yeah. So these are two things. Let's see what else we have. This is something. Let's see sound, actually. There may be some useful sound here. Or not this way. Sound cue. Oh, we don't not interested in sound cue. Or maybe we don't need sound. Can we just play it? This is a sound class. Oh, okay, so sorry. Okay. Okay, never mind sound. This tutorial will not include sound, but we can do it next time. If you will have questions, you can find things about sound in your docs. There is nothing difficult in blueprints or C++ to use sounds. But now we migrated our two assets. Let's go to reference first-person blueprint project that I have. If you migrated a different project, you probably did, just go there and you simply open the project. Don't save anything. You don't want to have any changes on this reference sen. Okay, this is gonna open fast. Okay, nice. So now you have this folder elemental here, and we have characters, effects, and environment. And here we have our Ice Knight effects. And you can see we have all the materials that are needed in order to make this thing work. And this is just perfect, yeah. So if we just put it on the level and start playing, yeah, it already looks pretty cool, right? And then we have this one, which is one time, and which is already looking cool. Nice. Of course, we don't want to put it on send just like that. We want to make something more complex and interesting. So now, when we play and we hit left click, we shoot. So we shoot a ball, and this is not really cool. Let's go to blueprints, to my projectile, which is the projectile that we shoot. It's a blueprint, which is a child of an actor class. It has some things inside, such as when it hits something, it adds impulse to location and destroys itself. And in some situations this is cool, but you can see what happens here. When it hits something, the thing goes flying away with some impulse, but then the ball gets destroyed, and it's not the thing that I would like to have when we will have our ice bolt, or whatever you call it. So let's make things funny, let's not destroy anything. And now you can see that they bounce around these balls, and they get self-destroyed out of 3 seconds. And this is just fine, so because we don't want to make much things to my projectile, let's do things to a copy of projectile. Let's call it my ice projectile. Yeah. And now let's have it here. It has the same functionality and has the same appearance, and we are not interested in having the same appearance. So this is a sphere, and we will not rename this component, but we will change its appearance to something like, for example, rock, right? Because it's an ice projectile and stuff. So let's rotate this rock 90 degrees. Remember, I hit a space key to switch different transform modes. So let me just make it a little bigger. This way. Now it looks like something like an arrow or whatever. And let's find it in content browser, and let's do one cool thing. Let's select it here, then we go to our elemental, and here we have materials, of course, like frost materials and stuff. Let's see, let's look at this material. Probably it's not compiled. Okay, here it is. Well, it doesn't look really cool, but let's see what happens if we put it on our rock. This rock, we select it, then we go here, we click this button, and here we go. This is what will happen when you apply this material to the rock. Well, it is something actually. So let's go to my ice projectile. Here we have a rock, but then if you scroll here we have material. So now this rock has the material, which is no restore. Please don't restore, yeah. Which is a default material for this static mesh. But if you add your own material to the 0 index, you can go to the let's see how it's called, mfrost. You can override and you can say mfrost. Yeah, good. Now you have this my ice projectile, and it doesn't have anything fancy yet. So let's go to my character. Nor not. Yes, let's go to blueprints, because everything is blueprints now, and we're interested in my character. So this is the guy who has all the functionality. This all can be written in C++, of course, but I started a blueprint project, so you may not have anything there, keeping this in mind. And shooting mechanics is also here. This is spawn projectile mechanics, okay? We're interested in doing quite the same stuff. We want to play animation, spawn actor, and yeah, play sound. Not now. So yeah, let's spawn our projectile when we hit Q button, for example. Yeah, you just put Q here, and it automatically goes to the key events. So when we press, what happens? Well, first of all, let's forget about animation. Let's just spawn a projectile. So we just can say spawn actor from class, and well, the class will be my ice projectile. So here you just write my ice projectile. Here you go. This is what will happen. But now we need to create a transform, which is a combination of location, rotation, and scale parameters. And what you can do is you can just take this code and put it here. Spawn transform. And it will take your location. It will add some gun offset. And yeah, it will spawn the thing with a scale 111. Let's see how it happens. Oh, sorry, I have it on a different screen. Let me just carry it around here. Okay, so Q, right? Okay, here we go. So if you look closer, you will see that this ice projectile runs. Of course, it doesn't look fancy and it doesn't make any sound. So the sound is a different story, but what I want to talk about first is that this is a spell, right? So it's not just an ordinary ball or something. We don't want it to fall down, basically. It just flies straight, like a real spell. So here we have this physics, and there is this enable gravity. You know, forget about enable gravity. And I guess everywhere we just say forget about enable gravity. Yeah. Let's see if this is the right thing to do. Oh no, it's not. Let's close this window and go to my projectile. All right. Yeah, probably we should be here. Yeah, projectile gravity scales, or it should be here. So these are just meshes and components which have physical representation. Basically, that's it. And this collision component is responsible for colliding with stuff. But when you make a projectile and you add through C++ or blueprints this projectile component, it manages a lot of useful stuff that you don't want to invent yourself, because this will take a lot of time, such as bounciness, initial speed, projectile gravity scale, and that's what we want. 0 gravity scale, right? So what will happen now is that, well, it just flies straight lines, which is amazing, right? Let's make it a little bit bigger. Like, for example, let's lock this. If you put a lock here, it means that any scale you increase, all the scales will be increasing in the same way, in the same amount. So let's put here. Oh no, not sorry, not 1. 0.3. Yeah, that's a big ass projectile, or even like that, I guess. Now the problem is that we want our collision component to be bigger now, right? I'm sorry, Skype. Yeah, sorry for that, guys. Let's just make a sphere radius bigger, like 50, I guess, or 35. And then, ideally, the projectile will be flying this direction. So we don't actually care about the tail of our big icicle, essentially. And what we can do is that we can move our icicle back here, so that when something collides with it, it will be, of course, colliding with the collision component. And it will be fairly realistic. So when this reaches something, the collision component will be invoked. Let's see how big is it. I think it's too big, but let's see. Well, it's good enough. Yeah, it's good enough. It looks lame, of course. Yeah, too lame. So what we can do with it? Well, first of all, we have some really fancy particle systems here. Let's take this particle system, let's add it here. So we have add components, and here you just say particle system, yeah? And here we actually go. And this is really big and fancy particle system. Let's not even rotate it. I guess it's good already. Maybe we will have to manage a little bit its size later on, but for now, let's see. Boom. Yeah, well, we definitely want to manage its size. Let's make it something like 0.7, I guess, yeah? And we play and we see what happens. Yeah, it flies the other direction that we want. So let's take it and let's rotate it 180 degrees on the z-axis. I don't like this blinking, but yeah. Let's see. It should work now. It should look good enough. Yeah. Yeah, I guess it does look good enough. Well, it's not the best thing ever, but you certainly can work with this more. Now, what's cool is that when this thing collides with something, it can do many stuff, not just an impulse to this location. Well, first of all, let's get more impulse. Something like 500 impulse, yeah? It doesn't have pretty sound, and the sound is very important when we talk about you know, magic and stuff, but yeah, let's forget about the sound for now. Let's add here something really cool. Let's just spawn a emitter at location, yeah? And important thing here, you say auto-destroy. What this means is that we have this nice emitter, and if we go here, we can see that it has only one loop. What does it mean? Is that it has a looping animation, this one, boom, 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 and then it disappears. And this is one loop. And then we can put here kill on completed, right? Save. And what this will do is that when this animation is played, that I show you right now, the emitter will self-destroy, and this is important for performance. So now let's take this emitter, as we saved it, and let's put it here. And we have this hit location. Let's just take this hit location information and put here. And rotation, oh, forget about rotation for now. So this emitter will be spawned there. Let's see how does it work. Of course it will be crazy. Yes. This is the thing. This is the thing. Now you see this giant artificial lens flare. We don't want it actually. I personally don't like it here, so let's destroy it. Let's find it and destroy it. Is it this one? I guess it is. Let's see. Let's restart simulation to see this again. Yes, so soft flare there. You may not delete it, you just, you know, disable it. And I guess this one also, yeah. So let's see now. Yeah, okay, good, it works, I guess. It's working more than fine, you see. So when this thing hits something, it makes this kind of storm there. And please keep in mind, when it hits BSP geometry, it doesn't do any, it doesn't invoke any hit events, because BSP geometry doesn't invoke hit events in general. So we don't have any sound here, and it's really sad because we cannot feel this kind of, you know, big projectile flying around. But it certainly works. Let's make this ice slower, maybe. Oh, sorry, smaller. This emitter. So we take return value, we say scale, set world scale 3D. Let's set it something like 0.7 and 0.7 and 0.7. Let's play and see what we've got. Yeah, it's just smaller. That's nice actually. So it's nice looking projectile. This is really small amount of information maybe that you learned here, so I would like to make something more fancy. Let's go to the blueprints and let's make a new blueprint. I don't know why the shadows are blinking there, never mind. and it will be an actor class blueprint, and it will be named something like Thrust Storm, I guess. Yeah. Let's open it, and what happens is that when you place it somewhere, we call event begin play. Yeah. It would spawn several emitters. So let's make a loop actually. Yeah, for loop. Oh, is it for loop? Let's see. Yeah, for loop. Let's add a new variable here, which will be an integer variable. It will be called iterations, for example. Very simple. And let's compile it and say that default iterations are 5 iterations. Yeah. Let's get this variable. Last index will be here. 0 index is 0. And the loop body. Well, the loop body will be spawn actor from class, and the class will be now our my eyes projectile. Right? This projectile, yeah. Well, then you will ask me, where would you spawn it? Well, the thing is that we can get our location, yeah. And let's see if we have a random location. Yeah, we don't have, I guess. Yeah, we will need to use bounding boxes. Never mind. Okay, so we have this location, and this is the location where you would put this frost storm, right? Well, then let's take this and add a vector, and the vector will be made from a random float variable. So make vector. Yeah, we'll need 3 variables for this, and in terms of z, let's keep it 0, so it will spawn at the same height. Yeah, and for x and y, we can say random float in range, and the range will be from, let's say, from minus 500 to 500. Of course, you can add it here as a parameter, but let's do it later. So here we go. This is random location. This will be a square location. So it's not like a circle. To make a circle random location, you will need sine and cosine functions. But for now, just never mind. So we need a transform. So let's make transform. We have a location, and let's keep the rotation 0, 0, 0 for now. We don't spawn if it's colliding, and it will be spawning for 5 times, right? Great. So it spawns when we hit event begin play, which is fine for tests, right? So this is a frost storm. Let's see actually. We have a frost storm. Let's put it somewhere on the map. Yeah, let's give it a physical representation actually. Let's give it let's say a box. Really simple. Yeah. And it will be called something like main body. Never mind. So now we have our thing here. And let's put it somewhere up. And as we are not testing anything outside of this blueprint, we don't need to hit play. We can hit simulate. Let's see what happens. Okay. Some things or stuff happens. Let's see again. Okay, so projectiles do spawn, but they spawn the wrong rotation. Let's rotate them, I guess. 90 degrees on Y. Let's see what happens. Oh, no, wait. Let's see from here. Oops. Simulate. Where does it? Yeah, okay, it happens here. Let's simulate again. Okay, just the wrong direction. Okay, great. Go back here, and we say minus 90, yeah? And we do again. Boom. Okay, they bounce. Just perfect. So I showed you how to make them bounce, because they bounce by default from here. But now let's go to our old idea that they don't bounce, they just get destroyed in this particular situation. Of course, you can make a copy of my ice projectile and keep the ones that are bouncing from the ones that are not bouncing. But okay, from here, let's say destroy actor and destroy self. So now you will see what happens is that let's make them also fly slower. Okay. Projectile component, and initial speed is something like 1000. Yeah. Sorry if I'm speaking too fast. Okay. Boom. Yeah, well, something happens and they still bounce. Let's see why does this happen. Okay, let's say we shouldn't bounce. Yeah, right, they don't generate hit events when they hit BSP geometry, I guess. Is it? Yeah, it says a BSP geometry. Let's see again. Boom. Yes. Okay. So one thing, of course, you can do is you can replace this BSP geometry with the static mesh, and in your map you will typically have this as a static mesh. But we will not bother about this right now. So let's do something else to make them look fancy. I see that they are not spawning random enough. Yeah, right, I forgot about y-axis. So if you take this one and you just connect it here, as far as I remember, it will be the same float, so it will generate it one time. So let's take another one. Let's put it here, yes, and let's simulate. Boom. Okay, so there are 5 projectiles. They just fly down. Okay, nice. And of course, we want something really more fancy. So there are many ways to do fancy stuff now to make it a real, let's say, frost rain. And I will show you one of the simplest ones. So let's see here, let's add a variable called spawn rate, for example. Yeah, it will be a float. And we can make a tooltip that the rate with which the projectiles are spawned, right? And some people do use event tick, but I really strongly suggest using timers, because event tick ticks really a lot of time, so it is really every 10 milliseconds or maybe 15 milliseconds, something like this. You don't want this. You want to have a timer which will be ticking every now and then, specifically every spawn rate. So this is a second spawn rate, so we say, okay, 0.5, which means 500 milliseconds. And how do we make these things be called every 500 milliseconds? Well, let's put them into function. Let's actually collapse to function, yeah. And we call this function spawn ice projectile, yeah. So I showed you the way how you spawn multiple projectiles at the same time, but this is not really, you know, looking really fun. So let's not make this for loop. Let's spawn one projectile at one function call, shall we? Okay, and the rotation, of course. So let's make it more random. We say make rot, and the pitch and roll we're not interested in. But in yaw, we saw this minus 90 is fine. It points them down, but we want more, you know, more variety, and maybe we will modify pitch also later on. But for now, let's say we want a local variable, which will be yaw, let's say, and we can set the yaw to minus 90, yeah. And we do that here, for example. Yeah. So this is minus 90. We established that. Now let's get this variable. And as a yaw, if we just put it here now in a yaw, the projectile will be facing down and will be flying down. But now let's add some random float here. So we say float plus float. And this will be a random float in range. And this amount of this randomness, of course, can also be adjusted. So we can add a variable and we say that it is called your range. Yeah. And of course this is a public variable, we want to adjust it from outside, and spawn rate is also public, but iterations we don't need anymore, we don't use it. Yeah, no work here. And now that we have this your range, let's compile again, and we say this your range, it's in degrees, so let's make 15 for now. Okay, so your range, we get it. We say that maximum is your range, but minimum is minus 15, right? If the your range is 15. So let's take your range again, or you can use this one, and you say that multiply it. Float by float, and you just put here minus 1. Oh, sorry, not minus 4, minus 1. And now this is 15, this is minus 15, just perfect. Let's make it even more fast. Here and here will be minus 1. Yeah. Okay, random range and float, random float and range, sorry. And we put it here, yeah. I guess this is just good. And this is the function, so it spawns one projectile and returns. And you will ask me, well, why do you need this function? Come on. Well, I will respond to you. Because I want to set a timer. I'll set timer. And here we go. And we say that when we begin play, we already set this timer. And the rate is this rate. Well, we need to specify a delegate name. In C++ it takes a little bit more code, but here we just write spawn ice projectile, because this is the so this is the name of our function, right? So this is spawn ice projectile. I hope I wrote it in the right way. I guess this is the small letter. Yeah, good. Function name. So this will be happening every time in a while. So let's see, does it work now? No, doesn't seem to be working. Let's see. Yes, write the object. Object is self. This should be fine. Spawn ice, yeah, right. I guess also this thing should be like that. Let's see now. Okay, right. So it happened one time, and yes, it doesn't happen again. Well, it should be looping, right? And now the next thing is that it flew in the wrong direction. Let's see. Let's disconnect this node for now. And we say that rotation is on yaw is minus 90. Oh, sorry, minus 90. Perfect. And let's see how does it happen. Well, here we go. This is a really primitive storm. But we want some variety here. So let's see. The yaw should be. Okay, let's track it more here. This is minus 90, yeah. Let's see, does it work very well? Yeah, it doesn't work well already. Well, why? This should be good enough. Why it's not good enough? I don't know. Well, actually, let's just say 0 here and let's see what happens. It just flies different direction. Okay. And let's put here 180. It will be flying opposite direction, right? And so it means that 90 is fine, right? Is it? Is it so? 90 is not fine again. Yeah, but why? And 0. Alright. Yeah, I guess now it's not the yaw. Sorry for that. Is it pitch? No. Alright, here we go. You just take this thing, you can go here, and you say yaw is not a yaw. Yaw is a pitch. And for pitch, minus 90 just fine. Let's see. Yeah, here we go. Now we added a little variety to this, and now we have this this kind of different angles around. So this is a really primitive ice storm, I would say. Yeah. Now there are some things, for example, they should disappear much faster, and generally they should disappear as soon as they hit the ground. So of course you can put here a static mesh set of this stuff. And yeah, this is pretty simple, so you can do this by yourself. I wanted to show you something else actually. Well, the cool thing is that instead of making it happen from the start, you can make your custom event. And then you can call custom event from, let's say, player. Let's try to do this. This will be the last thing for the tutorial because it's taking a lot of time now. There are a lot of improvements, but let's just finish with the custom event. So the custom event name will be something like activate, right? So when this activates, this is just what happens. And then we need something like deactivate, right? So custom event, we say deactivate. And when we deactivate, we want to reset timer. Let's see, we do a clear timer, right? Here we go. And the function name, we just copy it from here. Let's see. Control-C, Control-V here. So this is the way how it works, right? Yes, and well, there are a lot of ways what you can do now, but one thing that I would suggest is, or wait 1 second. Okay guys, so sorry for that little blink, probably for you it's a blink. Let's just finish this tutorial now. So how do you call these events? Well, you can go to the ice projectile and just close it, I guess. And what you will do is that you will take a normal projectile, which is let me see my projectile. So we still shoot this normal projectile, right? It still has a hit event. What we will do is that we take this hit event, and of course we have this hit location and stuff. Let's take this hit location and add a float to, or not to the vector. Let's hit this location and add another vector. Let's add a couple of meters, or even more, like 5 meters. And then we can spawn emitter at location and spawn actor from class, yeah? Again, we need a transform. So let's make a transform. Transform and rotation is 0. So now what we will be doing is that we will be spawning our first storm at the point where the hit event occurred. Here we go. And just keep it here like that. And now, if you will run the game now, it will be spawning, but of course we have our activate and deactivate events. And you can apply them in different ways, but for now let's just call activate event on it. So you can call it after some time, for example, or after some time you can deactivate it, or even you can just say delay sometime, like 2 seconds, and then just take it from here and you say deactivate. Great. Let's play and let's see. Yeah, this is one thing happened. So I'll spend some time and then they will be just, or not. Yeah, they are not getting destroyed. Let's see why. Clear timer is happening and things and stuff. This should be working. Okay. We can actually put a breakpoint here and see does it even occur. Apparently it never does. Okay. Let's disable this breakpoint, and I just remove it. Let's see. You call it on the same target. Yeah, apparently when you do a lot of this, you will lose this track of this object. Let's forget about this time. You can just, or let's see. Yeah, it should work, but yeah, never mind. Let's see. So this is some basic functionality that you can do with this frost storm. so it will occur every now and then. And of course, one thing you can do is that you can make them appear really high in the sky. So let's say something like 20 meters. And at the same time, go to ice projectile and say that it flies much faster. So we go to projectile, and here we say that its initial speed is something like 5,000. Yeah, alright, let's see. Yeah, that's more like it. That's more like it, yeah. So of course there are next steps that you could do. For example, you could add an explosion at the point when it collides the surface and stuff. And or of course you can just take this surface and fully replace it with a static mesh. Let's do this as a last point in our tutorial. Let's the simplest way to do it is that you just take a shape cube, you put it somewhere there, like low, and you say that it's really big, like 50 times big, 50, oops, no, not so much big, sorry. Let's just make it 50 and 50 times, and here it's 1 time, yeah. Okay, so now this is all a really big surface. And if you start playing, let's see, yeah, it works just fine. Now it's all a surface, so it all generates heat events. That's what you need to do. And it will be hitting objects and things and stuff. So yeah, this is a really simple and basic tutorial on ice projectiles and other stuff that you can find. Keep in mind there are a lot of cool effects in the Elemental demo and FX Cave partially, so feel free to take a lot of stuff from there. Really nice projectiles, particle emitters and stuff. Very nice art. Yeah. Okay, thank you for watching. I hope you learned something, and see you next time.